divided the ear into three parts. As the external ear, which consists of auricula or pinna, and external acoustic meatus, or the external auditory canal. And the middle ear, here is the middle ear. In the middle ear cavity, we have two muscles and three small bones. These are from lateral to medial. This one here is the malleus, and then here is the uncus, and this one is the stabus. This is the stabus. Stabus has a base. Here is the base of the stabus. Here you have the crura of the stabus. Crura. Here is the anterior crus or the limb. Here is the posterior crus or the limb of the stabus, sitting on the vestibular window or the oval window. And
like this a little bit.
this one like this one, okay. And on the auricula, if you look at the auricula, we have the helix. This is the helix. Its lower end terminates in the earlobe. It has a tubercle. It's called Darwin's tubercle. This is the Darwin's tubercle, and its upper end terminates here as the crest of the helix. This is the crest of the helix, and parallel but anterior to the helix, we have the antihelix. This is the antihelix. Upper end of the antihelix divides into crura. Look at this is the one. These are the crura. One crus, another crus. Between the two crura, we have the triangular fossa. This is the triangular fossa. There is a groove between the helix and antihelix. This is called what? Scapha. This is scapha. Scapha. Now the cavity anterior to the antihelix. Look at here. The cavity is the antihelix. Anterior to the antihelix, the cavity, this cavity, this one here, is the auricular cavity, or the cavity of auricle, which is divided into an upper small part, this one here, and a lower larger part. The upper smaller part divided by what? By the crus of the helix. The one above the crus of the helix is called cymba. This is the cymba. The one down and larger is called the kunja. Kunja leads into the external auditory meatus. External auditory meatus. Here we have, look at here we have the right where we have the trachus and antitrachus. This is the intertrachic notch. Intertrachic notch. This one here. Look at this one here is the. This one is the trachic. Okay, so the external auditory meatus is covered by skin, and outer surface of the, here is the eardrum, outer surface of the eardrum also covered by skin, external skin, the epidermis. The inner surface of the eardrum covered by mucosa. Mucosa is covered by mucosa. And if you look at this is the eardrum. Through the eardrum, we can see the manubrium of the malleus. Manubrium of the malleus. At the 5 o'clock position, you have the reflecting light. That is the cone of light. It's the cone of light. And here you can see the, look at this is the malleus. This is the uncus. Uncus has a short limb, a long limb. At the tip of the long limb, you have the lenticular process, which articulates with the head of the stabus, How about this one? What is this one here?
Compass.
This one is.
Long limb.
This is the chorda tympani. Look at this is the chorda tympani. Okay, that is the chorda tympani. Let's put this here, and then thank you. Can I have that one? Thank you. Look at this one. In the inner ear, in the inner ear, we have three structures. Anteriorly, you have the cochlea. This is the cochlea. Posteriorly, we have this semicircular canals. Inside the semicircular canals, we have the semicircular ducts.
This is the left ear.
It seems. Right. Okay. Now, the cochlea has 2.75 turn. One is here, this is the first turn. This is the second turn. Here is the 0.75 turn. 0.75 turn. At each turn, we have, look at this one here. Look at, this is the modulus. This is the modulus. Cochlea, or the cochlea turns around the modulus 2.75 times. And here, again, this is the modulus. Here is the, from down the above, this is the scala tympani. This is the scala media. This is the scala vestibule. Look at this one here. This is the osseous spiral process. This is osseous spiral process. Osseous spiral process projects from modulus to the cochlear canal, but does not reach to the lateral wall of the cochlea.
Can you repeat?
Look at this one. This is the osseous spiral laminae. Osseous spiral laminae, which also turns around the modulus 2.75 times. This osseous spiral laminae does not reach to the lateral wall of the cochlea. So the space between the tip of the osseous spiral laminae and the lateral wall of the cochlea, basilar membrane closes there.
Okay.
Right there we have the basilar membrane. Basilar membrane separates cochlear duct, or this is also known as scala media, from the scala tympani. And then, because there is another membrane here. This is called Reisner's membrane or vestibular membrane, which separates scala media from the scala vestibule. Scala vestibule. So we have 9 scala here. 3 scala. Look at 1, 2, 3 scala tympani. We have 1, 2, 3 scala media, and we have 1, 2, 3 scala vestibule. So you have three scala tympani, three cochlear duct or scala media, and three scala vestibular. Even though in the third term, I mean the 0.75 term, we don't have complete scala tympani, scala media, and scala vestibular. Again, the basilar membrane separates cochlear duct or scala media from the scala tympani. Reisner's membrane or the vestibular membrane separates cochlear duct from the scala vestibular. Oval foramen or vestibular foramen or the vestibular window open leads into where? Scala vestibular, right? You look at vestibular opening or the oval opening leads into here, leads into scala vestibuli. And this one leads to where? Round window or the cochlear window, which is closed up by a membrane. We call it secondary membrane. Secondary membrane. So this is the cochlea. Now let's put this here. The apex of the cochlea is called helicotrama, right there. This is the helicotrama. At the helicotrama, scala vestibula continues with the scala tympani. Scala tympani. Now, here is the vestibule. Here is the vestibule. Here is the vestibule. Right here, you have the vestibule. So this is facing to the, here is the, look at, here is the oval window. This is the oval window or the vestibular window. Back here is, this is the cochlear window. Cochlear window. So this should face like this one. Should face laterally. So this is the left ear. This is the left ear. Again, this is what? Right here, there. This is the oval window. Down it, this is the round window. Okay. Again, oval window. Here you have the round window. This is cochlear nerve. Cochlear nerve. This is the vestibular nerve. Here is the vestibular ganglion. Vestibular ganglion. Cochlear ganglion are found inside the cochlea, right here. Right here we have the cochlear ganglia. Cochlear ganglia. We have the cochlear ganglia. Okay.
I have a
Now,
question.
sure, go ahead.
Why does the ganglia look like a gland?
It looks like what?
A gland.
Gland? Well, that's the motor.
Isn't it supposed to be yellow?
No, doesn't matter. Man. Could be red, yellow, black, whatever you want.
Okay.
So it's an arbitrary coloring. Has no meaning. So here is the vestibule. On the vestibule, on its lateral wall, we have two windows. You can see that. So on the lateral wall of the vestibule, we have two windows. One is the vestibular window or oval window, and the round window or the cochlear window. Here is the medial wall of the vestibule. Vestibule is a bony labyrinth. Inside the vestibule, posteriorly we have little uterus. What do you call it? Utricle. And anteriorly you have succulus. Anteriorly you can it is the anteriorly you have succulus. This is the succulus. Now, on the medial wall of the vestibulum, there are an area called the maculae. Maculae contains
Receptor.
receptors that detect
Angle.
and help maintenance of the linear, our balance during linear acceleration, and also static our static balance or equilibrium. And then again, we have what this is called. These are the semicircular canals. Here is the superior or anterior semicircular canal, in which you have the anterior or superior semicircular duct. This is duct. And this is posterior semicircular canal, and this is the duct in it. And this is the lateral. Look at this, the lateral semicircular duct. Lateral, posterior, anterior, semicircular canals and ducts. So, this semicircular ducts open to where?
Vestibule.
Open the utricle, posterior wall of the utricle. At their entrance to the utricle, they have expansion. We call them what? Ampulla. Look at this is the ampulla. It is the you can see the ampullas here. Look at the ampulla is here, here, here. You can see the ampulla, ampulla. This is the common limb. It is the common limb for what? For anterior and posterior semicircular canals and ducts. Right one, this one. Entrance at the entrance of common limb, there is no ampulla. There is no ampulla formation of the ampulla. At the ampulla, we have receptors that detect our balance during rotational or angular acceleration, angular or rotational acceleration. Okay, these are what we have with the ear. So you should know the, do we have the bones, I mean the larger than these ones? Oh yeah, that's good. That's what I was looking for. Okay. Okay, thank you. Good. And then, good. Look at this one here. This is the malleus. The malleus has an head, has an handle of manubrium. Handle of manubrium here attaches to the umbo of the membranic, the tympanic membrane. And here you have the lateral process and anterior process, lateral process, anterior process. And then we can, right here we have a inguinal-malleolar joint, inguinal-malleolar joint. This is the uncus. Uncus has a body. Here is the body of the uncus. Here is the short limb of the uncus. Here is the crus or limb, the same things. Here is the long limb of the uncus or the long crus of the uncus. Look at this one here. This is at the tip of the long limb of the uncus. We have a lenticular process. this lenticular process articulates with the head of the stapes. Here is the head of the stapes. This is the lenticular process, okay? Lenticular process. Head of stapes. Do we have one more from this one? No. Okay. 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 No problem. No problem. It's okay. And then, here is the head of the malleus. I'm sorry, head of the stapes. Here is the base of the stapes. Base of the stapes sits in the vestibular window or the oval window. Yes, moves in and out, in and out. And this one here is the crus of the
Steps.
yeah, that should face like this. So this one should be here. Eardrum should be here. Okay.
Hocam where's chorda tympani again?
We don't have the chorda tympani here. Here we don't have the chorda. That's not it. This is the endolymphatic duct. It is the endolymphatic sac, endolymphatic duct. This endolymphatic duct connects endolymphatic sac to the where? Saccule and utricle. Saccule and utricle. Okay, let me pick up the brain here and show you the vessels. Look at here. Let me take this out, and this is the anterior cerebral artery. Anterior cerebral artery supplies the medial surface of the hemisphere back to parieto-occipital sulcus. And also 2.5 centimeters
Until the legs.
along the longitudinal fissure of the hemisphere, this area. And rest of the lateral surfaces of the hemispheres, because this is the middle cerebral artery. It is the middle cerebral artery. This is the middle cerebral artery that supplies the most of the lateral surface of the hemispheres. Okay? And then we have look at this one here is the posterior cerebral artery. Posterior cerebral artery supplies inferior surface of the temporal lobe and the occipital lobe, and also the medial surface of the occipital lobe posterior to parieto-occipital sulcus, this area. If you know this, that should be enough. Okay. Now we come to
John, what about body of wills?
body of what?
Of wills? Wills of...
Circle of Lewis.
Circle of Willis. Circle of Willis is here. Look at. If you look at this one, it is the circle of Willis here. This is what? Internal carotid artery. But here, unfortunately, we don't see the anterior cerebral artery. Anterior cerebral artery. We don't have the anterior communicating artery, which should be here, anterior communicating artery. This is posterior communicating artery here. And then this is the posterior cerebral artery here. And then this is the superior cerebellar artery. Superior cerebellar artery. This is the basilar artery. Basilar artery formed by union of the vertebral arteries. Vertebral arteries gives off posterior inferior cerebellar artery, which is known as pica, which supplies the lower one-third of the cerebellum. Before joining, vertebral arteries gives off a small twigs. You see these twigs here? These twigs join and form the anterior spinal artery. Anterior spinal artery. Then vertebral arteries join or merge and form the basilar artery. Basilar artery gives off AICA, anterior inferior cerebellar artery, and then gives off labyrinthine artery. So this is the labyrinthine artery. Between the AICA and labyrinthine artery, a nerve comes out. That is the abducens. And then basilar artery gives off pontine arteries that supplies the pons. And then basilar artery gives off the superior cerebellar artery. Superior cerebellar artery. And then basilar artery terminates via giving of posterior cerebral artery. Posterior cerebral artery. Posterior cerebral artery is connected to the internal carotid through the posterior communicating artery. But unfortunately, here we don't have the anterior cerebral artery. Anterior cerebral artery, middle cerebral artery, and the anterior communicating artery.
Will we be responsible for the tiny branches, like the ponte branch?
They are not here, so you won't be. But you will receive a question from here.
Just to clarify, in this picture, there are the pontine arteries.
That's right.
Is this the labyrinthine?
It is labyrinthine artery.
It's not identified.
It is
That's
not labeled there, but it's the labyrinthine artery.
why- Okay. And we're supposed to know that.
Yeah,
It's there.
it is here. Look at this is the labyrinthine artery here. You can see the labyrinthine artery. Labyrinthine artery.
And abducens emerges between labyrinthine
Labyrinthine and AICA.
posterior. Okay.
AICA. And two nerves exit between the posterior cerebral and superior cerebellum. Medially oculomotor, laterally
For trochlea.
trochlea. Laterally trochlea. Very good. And then now let's talk about the dural sinuses. Look at this is the superior sagittal sinus. Hey, superior sagittal sinus coming from here like this. Superior sagittal sinus. This is superior sagittal sinus. This is the transverse sinus, you see, transverse sinus, which continues as the sigmoid sinus. Sigmoid sinus. Transverse sinus continues as the sigmoid sinus. Sigmoid sinus drains into internal jugular vein. Internal jugular vein. This is what? Sphenoparietal sinus. Sphenoparietal sinus. This is cavernous sinus. Cavernous sinus. Here you have the posterior intercavernous sinus, anterior intercavernous sinus. Here you see the infundibulum or the stalk of the pituitary gland. And around it you have the diaphragma sella. Diaphragma sella. And then this is what? This one here is the superior petrosal sinus. Superior petrosal sinus. This is what? Inferior petrosal sinus. Inferior petrosal sinus. Right here, what do you have? Look at again, this inferior petrosal sinus. And back anteriorly, here you have a basilar sinus, right? Basilar sinus. Back it, this is the occipital sinus. Occipital sinus. This is the confluence of sinuum. Confluence of sinuses. Confluence of sinus. How about this sinus? Straight sinus. This is the straight sinus, right? This one. Straight sinus. And this is the superior sagittal sinus. Here is the occipital sinus. This is the transverse sinus. Generally, superior sagittal sinus continues with the right transverse sinus. Remember that? As in the model. As in the model. And that's what we have here. So we have covered the dural sinuses. If I label this one, you will say superior sagittal sinus. How about this one here? If I label this one here,
Can you show again?
this one here.
Confluence
Conf-
sinuses?
Confluence of sinus. What does confluence means?
Anastomosis.
Coming together.
Yes.
Coming together. Not really anastomosis. Well, kind of anastomosis, but coming together. Well, okay. And then this is the transverse sinus, then sigmoid sinus. This is the occipital sinus. This is the superior temporal sinus. Here is the inferior temporal sinus. If I label the nerves, this is the olfactory nerve. This is, if I ask you, name the type of nerve fibers found in the nerve labeled. SS? SSA. SSA. How about this one? SVA. SVA. SSA. SVA. And then right here, you have the oculomotor nerve. Look at this one. Oculomotor nerve. This is oculomotor. This is the trochlear nerve. And then you have the trigeminal nerve. Trigeminal nerve. Then you have the abducens nerve. Abducens nerve. Then you have the facial nerve, vestibulocochlear nerve. Then you have the 9, 10, and 11. Here you see the spinal part of the accessory nerve coming in from the through the foramen magnum, and then this is the what? Hypoglossal nerve. So we covered hypoglossal nerve. Very good. And then we come to here. This is the diencephalon. Here is the diencephalon. Right, it is the thalamus. This is the thalamus. Here is the hypothalamus. Here is the subthalamus. This is the epithalamus. You don't see the metathalamus, right? This is the interthalamic adhesio, septum pellucidum. This is the corpus callosum, is rostrum, genu, body, and splenium. This is what? Fornix. This is the fornix. That's the fornix. Here is the anterior commissure. Which pathway passed through it?
Olfactory.
Olfactory pathway. And how about this is the posterior commissure? Which pathway passed through? Visual pathway passed through it. How about this one? This is what? Pineal gland. Very good. Pineal. If I label this one, name the gland labeled, you will say pineal gland or epiphysis. 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 Very good. And then this is the terminal laminae, right? Terminal laminae. This is terminal laminae. And here is the pons. Here is the mesencephalon. Name the nucleus found here.
3 and 4.
Nucleus, not cranial nerve nucleus, other nucleus.
Substantia nigra.
So, and what else?
Wait.
Red nucleus, right?
Yes.
Red nucleus. Red nucleus is also here. Red nucleus.
But substantia nigra isn't completely in mesencephalon.
Which one?
Substantia nigra.
Yes, it
Most
is
of
inside.
it.
Most of it is inside. Mesencephalon. Mesencephalon. Name the artery.
Anterior cerebral.
Anterior cerebral. Name the artery.
Posterior cerebral artery.
Posterior cerebral. Name this artery. Middle cerebral. Middle cerebral artery. And okay, that's what we have.
Okay,
Not too bad.
not too bad.
You're doing fine.
Yeah.
So if you watch the videos,
This
you will
will
be
be
fine.
This will be enough only.
For the practical, yes.
Can we see the
No
limbic
spinal cord?
system?
Of course. Of course. There will be spinal cord. Yeah. And others. I haven't thought of them now.
Hocam, before the exam, can you please send us a question distribution?
What is that?
Question distribution.
I haven't decided that yet.
Yeah, I'm saying before the exam.
Hopefully I will do that.
Okay.
I will let you know. Even I will let you know the theoretical questions, how many questions I will ask
Thank you very much.
from each subject.
Thank you.
So you will know how many questions you're going to have from the diencephalon, how many practical and theory questions you will have.